Hey everyone, in today's video we'll be looking at the following question. So we have a fair coin that is tossed n times and we're asked to give the expected product of the number of heads and the number of tails. So have a think about it and I'll be right back with the solution. Alright, so to start off, let's define x to be the number of heads and y to be the number of tails we get after n coin tosses. Alright, and so now we're asked to give the expected value of x times y. So we'll just have e of x times y. All right, but what is y? Y is just the number of times we threw minus x. So actually you have here that y is equal to n minus x, since we can only have heads or tails. And so this is actually the expected value of x times n minus x, which we can simplify to e of nx minus x squared. All right, and so now by linearity of expectation, this is just equal to the expectation of n times x minus the expectation of x squared. And we can actually also take this n out. So this is just, n times the expectation of x minus the expectation of x squared. All right, so to find the expectation of x and y, we just have to find the expectation of x and the expectation of x squared. And then I guess we multiply this by n and then subtract the expectation of x squared. So first, let us note that x follows a binomial distribution. So if you've never heard of the binomial distribution, it's just the expected number of successes given n trials and some probability of success. So in this case, our number of trials is just n, since we tossed the coin n times. And since this is a fair coin, the number of successes, or the probability of success for getting ahead, is just 1/2. And so actually also, if you know, for any binomial distribution, the mean is given by n times p, where n is the number of trials and p is the probability. So in this case, this is n/2. And the variance, so let's say expectation of x is equal to this, and then the variance of x is equal to n times p times 1 minus p, which in this case is n times 1/2 times 1 minus 1/2, which is 1/2 as well. So this is n/4. Okay, so why do we care about the variance of x? Well, if you remember the formula for variance, the variance of any random variable x is just the expectation of x minus the expectation of x, this all squared. But this can be actually simplified to the expectation of x squared minus the expectation of x all squared. So the squared is kind of applied to this whole expectation here. And so to get this value, we just add the expectation of x squared to both sides. So the variance of x plus the expectation of x squared is equal to the expectation of x squared, which is the term we're looking for right here. And so let's try to find this term. Okay, so the variance here is just given by n/4. And this expectation squared, well, we know the expectation is n/2. And so the square of that would just be n squared over 4. And so the expectation of x, so this term here is just equal to n/4 plus n squared over 4. All right, and now similarly for this term, we know that the expectation of x is n/2. So n times the expectation of x is n squared over 2. Let's clean this up and try to solve the problem now. All right, so the expectation of xy is now just given by n squared over 2 minus n/4 plus n squared over 4. And so here we can multiply by 2 to give 2n squared over 4. And then this term is just minus n squared plus n over 4. And so the whole solution would just be n squared minus n over 4. This is actually, n squared minus n over 4. All right, I hope you enjoyed that problem. If you like these types of videos, please consider subscribing, and I'll see you next time.